This question is about the astronomy. Complete the sentences by writing a word in a blank space. Earth is astronomical object. One astronomical object smaller than the Earth. So you can mention moon, or you can also name planets as well. Two astronomical objects which are larger than the Earth, so Sun, Jupiter. Milky Way is a name given to our galaxy. The diagram shows a path followed by the comet as it moves around the sun. We have A, B, C, D, and E are the points on the comet orbit. Name the force that causes the comet to orbit the sun. So gravitational force is there, which is even for planets also. At which point shown is the force on the comet is greatest. So that is point B because it is closer. Draw an arrow at a point D to show the direction of the force. What will the direction of the arrow? Which direction the force will point? Yeah, force of a gravity on comet at point D. So it should point towards the sun because sun is pulling a comet. So you should draw an arrow towards the sun. At which point does the comet have the greatest kinetic energy? Closest. So because the total energy is conserved, the total energy is gravitational potential plus kinetic. That is the total energy. So least gravitational, so highest kinetic energy will be there. Next question, a comet passes close to the Earth. An astronomer observed the position of a comet and Earth on the same day. As you can see, the observer position and the diagrams were observed for weeks from week 1 to week 11. Like this is a position of the comet and this is a position of the Earth. The path of the Earth is shown with a continuous line and the path of the comet is shown with a dotted line. Position of the Earth in the first week is there and position of the comet in the first week is shown. Complete the path of a comet between week 5 and 7. Complete the path between week 5 and 7. It will be week 5, 6. Yeah, it should be like this because we have to draw. If you draw this one, they will reject. Why they will reject? Because you have to, the center of this should be a sun. And it's not like if sun is here, the comet will hit. So it should take a greater radius of curvature. Mark on X to show the position of the sun. Where we'll have the sun. So this position will be the sun. Suggest why astronomer did not observe the comet during 6th week. Why the astronomers did not observe when in the 6th week? Yeah, because the comet is behind the sun. That's what. Look, 6th week Earth. This is Earth, and 6th week this one is a comet. So means they are on the opposite side of the sun. That's why the observers, like astronomers, were not able to observe this. Like they're on the opposite side of. So sun is blocking the way, you can mention, or they're on the opposite sides. But it is behind the sun. That's also right. The observation showing that the comet nearest to Earth was made during which week the comet was closest to the Earth? Which week? Look, the simple way you can just draw lines from one, like example, this is week 1. So week 1 line is this long. Week 2, week 3, week 4. Sorry, I joined. This will be week 4. Week 5, week 6 will be here. And week 7, week 8, week 9. And then week 10, and then week 11. Which is the shortest distance? Week 9. So week 9 is the shortest distance, so week 9 is the right answer. Explain how the diagram shows the speed of a comet changes as it moves from position 1 to 5. So how it shows as it is moving from 1 to 5? It is yeah, it is increasing. And you can see this distance also, like the distance covered, because this diagram is for the same time scale. Like example, after every week they recorded the position. So week 1 and week 2, the comet cover shorter distance. Week 2 to 3, the distance is longer. So means the distance between so what is happening? So from week 3 to week 4, it appeared that the comet travel fastest. So from we have to explain by using a diagram. So the time scale is same. We have the formula speed is distance over time. So time scale is same, like it is every week it is done. So if we have a longer distance, means it has cover, it is moving faster. So means from week 1 to week 4, what happened? The speed of the comet increases. But from week 4 to 5, the speed of the comet decreases. Because we have to use a diagram to show that. Welcome, sir. Thank you. Suggest why the speed of the comet changes. Why the speed of the comet is changing here. So it is getting closer to sun, but you have to use a conservation of energy here. You will mention the total energy of the comet is constant. Whenever a question is there related to space physics about the speed of the comet or the planets, why the speed is changing, so you have to mention the total energy is conserved. That is always the point. If the total energy is conserved, so as the comet is getting closer to the sun, the potential energy is decreasing, so the kinetic energy should increase. So one point you have to mention the total energy is conserved. And then second point, you relate the potential energy decrease, so the kinetic energy will increase. The next is the Earth orbits the sun once in 365 days. The radius of the Earth orbit is, which is also known as 1 astronomical unit or 150 million kilometers. Calculate the speed in kilometer per hour. We have already this in kilometers. The radius is already in kilometer, but this we have to convert into hours. How to convert into hours? So 365 days multiplied by 24 multiplied by 60 only. To get the orbital speed, it is always 2 pi r divided by t. So 2 into 3.14 into radius 150 exponent 6, because 1 astronomical unit. Yeah, that's right. 365 days, because to multiply by only 24. It will be 60 if we want to convert into minutes. That's right. So 365 into 24. Yeah, it would be 24 only. By mistake, I converted into minutes rather than hours. What's the answer for the orbital speed of the Earth? Can you check? Because it should be around 30 kilometer per hour. 150 exponent. Oh, no, it's 30 kilometer per second. Sorry, not hour. Yeah. So what's the final answer? 10 to the power 5. Yeah, I remember it was 30 kilometer per second. That's the orbital speed in per second. Question 10, the table gives some information about different objects in the universe, and the description is given. Which of the object is a comet? So orbit the sun in elliptical orbit. So because it is elliptical, that's why it will be a comet. What is this? Orbit the star in almost in a circular path. What planet? What is the object? Large collection of billionaire stars. Galaxy. Orbit the sun, that is we just said comet. And orbit the planet, so it's a moon. So we just have to find which is a galaxy. So galaxy matches with the description of B, and this galaxy in our solar system. Which galaxy is in our solar system in? So it's in a Milky Way. In question 11, the diagram shows the orbit of Mercury and the orbit of the Earth. Describe two differences between the orbit of the Mercury and orbit of Earth. Use diagram 1 to help with your answer. Yes. What is the difference? Yes. Right. Yeah. So orbital length, because the difference in the orbit, so orbital length you will use. You can mention time as well. So Mercury orbit, and this you can also compare, like if you compare the center, so for Earth it appears that the sun is at the center, but for Mercury the sun is not at the center of the orbit. And the second thing, the orbital length for Mercury is shorter as compared to that of Earth. The diagram 2 shows the orbit of a comet and the orbit of the Earth. Describe two differences between the orbit of the comet and orbit of Earth. Circular. Right. So sun is not at the center of this comet orbit. Sun is the center for the Earth orbit. And the speed at which Earth move around the sun is approximately same, but for comet it will change. But that is not, it's just a difference, but not related to the orbit. Orbit in terms of length you can mention. Question 12, the diagram 1 shows the orbit of two objects. State the word, complete the boxes. Screen. Do one thing. So select a word. Diagram 2 shows a moon orbiting the Earth. Draw an arrow on diagram 2 to show the gravitational force acting on the moon. Give a name for a large collection of billions of stars. Galaxy. Question 13 also related to this question is about the stars. The diagram shows the orbit of two astronomical objects around a star. Add an arrow to a diagram to show type of force from star acting on object A. What is the type of the force? Add a diagram to show type of force acting, and so that will be a gravitational force which is acting toward the center. What is object A? And object B is a comet. You have to label on the arrow as well. So object B is a comet. State a name given to a large collection. So we call them as a galaxy. When repetition is there, um, physicists classify stars according to their color. Each group of stars similar color is called a spectral class. Like say if a star appear blue white, so it belongs to spectral class B. The table gives information about the color and the surface temperature of three spectral classes. The sun belongs to spectral class G, which is having a temperature of 5600 Kelvin. Complete the table by suggesting a value for the missing surfaces. Look, remember one thing, the color intensity depends on the temperature of a star. Like we have violet, indigo, blue, green, yellow, orange, and red, or we write the other way around, like VIBGYOR, Vibgyor. So if the temperature is low, then it will appear in this region. If a temperature is high, it will appear in this region. So sun, you don't have to memorize this value, you just have to estimate here. So this is just estimation. It's like the range of answer will be there for this one. So yellow sun is here. This star appeared to be blue white, means this region. What could be the temperature? So it should be higher. So you can just make it double, like 5600, you can write 11,000. Any value, but higher than 5. And this appear orange and red, like this region. So its temperature should be lower. So you can write 2500, 2800, any value, but less than 5000. So 3000, any number you can write, but it should be less than 5600. So the color of the star depends on its temperature. And violet, indigo, higher, like longer, higher frequency or shorter wavelength means higher temperature of the star. There are stars in the universe with a mass much greater than the mass of sun. Describe what happened to these high mass stars when they leave the main sequence. So first we have a main sequence star, a high mass star. After main sequence, what it will turn to? So it will turn into supergiant. After supergiant, explosion, supernova. And supernova, from supernova, it leads to what? Yeah, it could be a neutron star or a black hole. So you have to learn like star cycle as well. Question 14, planets and moons in solar system moves in orbit. Name which we give, that is we call a gravitational force. Then on the diagram, so you have to label, diagram is not to scale. So which one is this? Star, planet, and the moon. Explain how time period of a moon is different from a time period of a planet. Yes. And why it is shorter? Yeah, radius is shorter. That's like, or the orbital length is shorter as well. You can mention. One is you can relate the length, orbital length, or you can compare the orbital radius, and then moon, Earth is, or the planet is orbiting the star, having a longer orbital distance, so take longer time to orbit as compared to that of moon. Question 15 shows a Hubble and the Kepler's are the names of the two telescopes. You can see this one is a Hubble's telescope, this was a Kepler's telescope. The Hubble telescope is in a circular orbit around the Earth. The Kepler is around the Sun. So the orbit of the Hubble most likely to be like the orbit of the moon, and the Kepler one, it is orbiting the sun, so it will be like a planet.
Planet.
Planet or comet also it is. The orbit of a Kepler telescope most likely the orbit of a, so we have options are there, we have comet is there, moon is there, planet, but it's likely to be a planet rather than a comet one, because comets are starting from edge of the our solar system and then reaching the sun. The force that keeps space telescopes, that is the force of a
Gravity.
the space telescopes are used to study the galaxy. Use a word from the box to complete. There are billions of stars in the galaxy, which we call. And there are billions of galaxies in the universe. You can use your mic. You can also use chat or screen annotation. Which of these nearest to the Earth? So moon is closer. Gravitational field strength is measured in what is the unit of gravity? Newton per kilogram. Or meter per second square also it is acceptable. Because that's the acceleration due to gravity, also a unit of gravity it makes. Question 16, the diagram shows the orbit of some objects in our solar system. The path X is the orbit of what? So it will be orbit of the planet, and path Y is the orbit of the comet. The objects are held by a gravitational force, so C will be the right answer here. This is a Hertzsprung and Russell diagram. It shows how the astronomical objects evolve with the passage of time. Like different types of stars are their main sequence. And this is blue, white, yellow, and red. So what will be the temperature scale in this order? Increasing or decreasing?
Decreasing.
Because blue should have a high temperature and red should have a low temperature. Actually, what it shows the main sequence star like a relation. If a temperature is low, then its luminosity or absolute magnitude or how much light it is giving out, that will be less. If its temperature is high, then it will show high luminosity. If it is like say moderate temperature, then it will show a same luminosity as like our sun. But these are white dwarfs. What are white dwarfs? White dwarfs have high temperature but low luminosity. Why? Why white dwarfs have high luminosity, high temperature but low luminosity? What could be the reason?
Because they are small in size.
They're small in size because the size is so small that it overcome the high temperature. And red giant, even though the red giants have a low temperature, but why they're more luminous? Because they're larger. So red giants, because of their size, they appear to be much brighter than white dwarfs, even though because the intensity or the light which we receive from the star depends on two factors: distance from us, and it also depends on the temperature and the size of the star. The question was actually related to about the Hertzsprung-Russell diagram. That is not part of the syllabus. I just add the question to explain the relation between them. Which of the following is responsible for keeping a satellite the gravitational force, and which is the largest? The universe is the largest. Which of these represent the brightness of star as a standard? Um, Leave this one because it's not standard candle is not, you're not learning standard candles. The brightness of star is here refers to absolute magnitude, but you're not learning anything about it. The Doppler effect, a toy produces a continuous wave when floating on the surface of a pool. Diagram 1 shows what is produced by the toy, and diagram 2 shows the wave fronts. Draw an arrow on the diagram to show the direction where the toy is moving, right or left? Good. So which direction the toy is moving? It's moving towards the right. Why? Because the wavelength is getting shorter. That is a Doppler effect. Doppler effect means it's a relative change in frequency or wavelength when the object moves relative to the source, relative to the observer. If it is moving towards, then the wavelength will get shorter and the frequency will be higher. If it move away from us, then the wavelength will be longer and the frequency will be shorter. So means this toy is moving towards right. Explain how the frequency of wave at point A is different from frequency of wave point B. First thing, speed will be constant. Yeah. So, but whenever you relate frequency and wavelength are changing, you have to say speed is constant. So the one point you will mention, the speed of the wave is constant. If the speed of the wave is constant, we have the formula V equals F lambda. Because A will receive more number of the waves, so it will receive a shorter wavelength. And for B, what will happen? That the number of the waves which it receives will get less, so the wavelength will be longer. So for B, how the frequency at point A, so for A, higher frequency, shorter wavelength, and for B, shorter frequency or higher wavelength or longer wavelength, because the speed is constant. Speed of the wave is constant for both of them. This question is related to the Big Bang. Give two pieces of evidence from the Big Bang theory, like from the how we are convinced that the Big Bang happened. One is the cosmic microwave background radiation. What is cosmic microwave background radiation? Look, according to Big Bang, it all started with explosion. So the moment when it all started, the universe was so dense. The universe was so dense that any radiation which were emitted out from those particles were trapped. Then what happened as a universe cooled down, like as it according to Big Bang is expanding, we are saying universe is expanding. So as a result, what will happen when these particles move away from each other, as the spacing between them increases, now this light get chance or this wave get chance to come out. When we receive this wave, we call this as a cosmic microwave background. Why we when we receive this wave, what we observe that this wave is much longer than what it should be, like its wavelength has increased. So that is one piece of evidence. And another one, most of the galaxies are giving a red shift. There are blue shifts as well, but most of the galaxies are giving red shift. That's also an evidence that the universe is expanding. So cosmic microwave background radiation and the red shift or the Doppler effect are the two reasons. Even Doppler effect is happening here as well. Like these radiations might be gamma rays, but when we are receiving them now, we are receiving as microwave. So we are receiving them as a much longer than what it should be. It shows that the universe, they are moving away from us or the universe is expanding. Then, so two pieces you have to mention and then how this evidence support the Big Bang. So 2 marks for cosmic microwave background radiation, which were released from the beginning of the universe. Most of them were gamma, but or very high frequency. But when we receive them now, we are receiving in a microwave region, which shows that the wavelength has increased or that part of a universe is moving away from us. And the second one, most of the galaxies are giving the redshift. So which shows also that universe is expanding. So this is a very important question to learn. This question is about the star. Describe the stages evolution of a star which is similar to that of our sun. So first it will be a main sequence, and then from main sequence it will be a red giant. Red giant, it will be a planetary nebula. From planetary nebula, it will turn into a white dwarf. And then black dwarf will be the theoretical. But you have to mention, like, it's not like just mentioning the names. You have to explain each state, like when it is a red giant, the radiation pressure, what happened to radiation pressure and the gravitational force. The process of energy release in the core of a star is different from the process of energy in a nuclear power station. How these process, how the processes of energy release are different. So in a fission and fusion are there. That's right. So in a nuclear reactor we have fission, and in the core we have a fusion. And a fission heavy break down into lighter, and in a fusion lighter join to form heavy. But both of them are exothermic reaction. Both of them release energy. This passage describes the evolution of the star with a mass much larger than mass of sun. Use a word or the phrases from the box to complete. Each word or phrase may be used once, more than once, or not at all. Hydrogen atom. Here is the whole passage. So yeah, this is a whole passage. Okay. So first, hydrogen atom in a nebula moves towards each other due to a gravitational force. As the atom move towards each other, their dash energy stored increases. So which can, because they move closer, so gravitational potential decrease, so kinetic energy increase, which increases the temperature. If the temperature become high enough, the nuclear fusion of a hydrogen will start. This is actually the whole description of the star cycle. And star enter the main sequence star. When the hydrogen fusion stop in the core of a star will start to expand, because the radiation pressure, it should expand or contract. It should start to contract. Why it will start to contract? Because when the radiation pressure, because the fusion stop, or it's not like fusion stop, rate of fusion decreases. When rate of fusion decreases, the radiation pressure, the outward pressure is less than the gravitational force. So as a result, what will happen? The core will contract. So it should not be expand, it should contract. This increases the temperature in a layer surrounding the core, and the hydrogen fusion restart, and this causes the star to expand, and its surface temperature decreases. The star now is a red giant. Eventually, the nuclear fusion stop and the star explode. So that will be a supernova. And the core of a star collapse to form either a neutron star or a black hole. Not white dwarf. White dwarf is not a possibility for the low mass, for a high mass star. So you cannot write white dwarf. Then we have a red giant, which has a mass much greater than the sun. Describe the evolution, entire life cycle. So how it will evolve? Entire life cycle. So first it will be a protostar with a high mass, main sequence. Black hole. And mention about the radiation pressure and the rate of fusion which happen. Then discussion about space and all galaxies in it is called universe, a large collection of billions of stars. Galaxy, sun and its collection of planets, moon is called solar system. Then we have the diagram shows the orbit of the comet around the sun, at which point the comet is moving fastest. So A, because it is closer. Name the force that keep the comet orbit the sun. So gravitational or gravity. You have to match the description. Just a minute, let me zoom in. Yeah. So 1 day is what? So time to 1 day, time for Earth to rotate once. Then the diagram shows two objects. Object X has a circular orbit and around the star. State the type of object that has circular, so planets. Then object Y is elliptical, the type of object comet. And the object X complete orbit in 35 days. We need the orbital speed. The distance is given. So V is equals to 2 pi r divided by t. So it will be 2 into 3.14 into 10 to the power 11. In 35 days, we convert multiply by 24 into r, multiplied by 60 and multiplied by 60. So our final answer will be meter per second. So 3.12 exponent 5 meter per second. Then the Big Bang suggests the universe is approximately 14 billion. Describe evolution of the universe from a Big Bang until today. So you have to explain the same idea, like the universe was very dense and hot, and then as it exploded, the momentum, total momentum should be conserved, so everything is moving away from each other. And what is the evidence that the universe is cooling down? That is the cosmic microwave background radiation which we receive. Show the redshift, and it is, and describe the evidence support the Big Bang theory. That's the same question, the cosmic microwave background as well as the redshifts. So this was the whole exercise related to the space physics. Any question or doubt?